Why are magnesium hydroxide and calcium hydroxide classified as strong bases, even though their pH is only mildly basic? So this is a common misunderstanding. When students see the word strong base or strong acid, they like to correlate that with pH, and they shouldn't do that because pH is correlated to inversely to the concentration of hydrogen ions. So if you have a lot of hydrogen ions, you're going to have a low pH. And in this case, since we're talking about bases, you can say the pOH is also correlated to the hydroxide ion. And they're all related. So you can also say the pH is directly correlated to the hydroxide ion. All right, the more hydroxide ions you have, like these are bases that are going to release hydroxide ions in water, and they're Arrhenius bases. The more hydroxide ions, the higher the pH. So we know pH greater than 7 is indicative of bases. So why are these pHs not as high as some like sodium hydroxide of the and it has to do with the solubility. So the strength of, if we say something is a strong acid or base, we define it that way because they ionize. All right, so when you put this stuff in water, they completely 100% ionize into, in this case, their cation and then their hydroxide ions. But in the case of group 2, like magnesium, calcium, group 2 metal hydroxide compounds, we learned in our solubility unit that hydroxides are generally insoluble. Now your group 1 metal hydroxides are always soluble, but calcium hydroxide, it does not dissolve well in water. And we work with this in our lab, and it just, you don't dissolve much of it, just precipitates out, or you give it enough time. And so it's like 0.1 or 0.2 grams per 100 milliliters. But that little bit that does dissolve is going to 100% ionize. That's why it's classified as a strong base. But it doesn't mean there's a lot of hydroxide in there. All right, so that's why there's not a lot of hydroxide in there, so pH is not going to be that high. And as you go up the periodic table, like magnesium is even less soluble. We wouldn't even consider that soluble. It's like 0.01 grams per 100 milliliters, and these are all at room temperature. All right, so, but the wee little bit that magnesium hydroxide does dissolve in water, that little bit, 100% of it is going to ionize. So that's why it's classified as a strong base. But again, that doesn't mean there is a lot of hydroxide in there, and therefore you shouldn't correlate the word strong acid base with necessarily high or low pH.